This video is for section 13-4, Geometric Progressions. We've discussed arithmetic progressions, where there's a common difference between terms. Now let's discuss geometric progressions, where there's a common ratio between terms. What this means is you multiply the same number from term to term. In an arithmetic progression, you added the same number to get from term to term. A geometric progression is a sequence of numbers in which the ratio r of every pair of successive numbers is a constant. In this example, which sequence is arithmetic and which is geometric? So what you're looking for is, do you add the same number to get from term to term, or do you multiply the same number to get from term to term? This one here looks like adding 6, adding 6, adding 6, and so on. This is arithmetic. But this one here, what's going on from term to term? It's multiplying by 4 each time. So that's geometric. So the word geometric, as we're using it here, is not referring to shapes or geometry class. Geometric in an algebra class refers to a pattern of numbers where you multiply to get to the next number. Let's use the symbol A again to mean the first term of the sequence. We'll use the symbol R to be the common ratio, and then we can create a formula for the general term. Here it is. So T sub n equals the first term times the common ratio raised to the n minus 1 power. Here's an example problem which we can solve with that formula. What is the sixth term of this geometric progression? So we want to find T sub 6. The letter A is the first term, that's 3. Now we need to multiply by the common ratio R. Well, we first need to find that. So what's happening from term to term? It's multiplying by 4. The value of R is a 4. And then we're going to raise to the n minus 1 power, so that's 6 minus 1. This is equal to 3 times 4 to the 5th power. You can take a calculator to evaluate that. The answer is 3072. If you extended this pattern out and continued to multiply by 4, when you got to the 6th term, it would be 3072. You would have multiplied that number by 4 5 times. Next example, write an expression for the nth term of this sequence. Well, what's the pattern from term to term? The terms are getting smaller, so it's either subtracting a number or it's dividing by a number. In the first case, it divides by 3. Does that happen from there to there? 13 divided by 3 is 4 1/3. Yes, that is the pattern. So because it's division from term to term, this is geometric. So T sub n equals, now the first term, that's 39, times the value of R, which is 1/3, because we're dividing by 3. Division by 3 is the same thing as multiplying by 1/3. And our exponent is n minus 1. Next example. There are two geometric progressions of real numbers with a first term of 7 and a fifth term of 112. Find the two values for R. So what's going on is there's a sequence of numbers. The first number is 7. Then there are 3 numbers. We don't know what they are, but then the fifth number is 112. We're told that there are 2 possible values of R that you could be multiplying by each time. Let's use our general term formula to get this answer. So we have T sub n, and for n, let's use 5, because we know the fifth term is 112. And that's equal to the first term, 7, times the value of R, raised to the n minus 1 power. In our problem, let's use 5 for n. Now T sub 5 is 112. So we have 112 equals 7 times R to the 4th power. Now divide by 7 on both sides. And that makes 16 equals R to the 4th power. Do you see why the directions say we're going to get two values of r? Because to solve this, you take the fourth root of both sides. But when you take an even root, you have to do plus minus. So our answers for r are positive or negative 2. Let's summarize the lesson. We discussed another type of sequence of numbers. Instead of an arithmetic sequence, this time it's geometric, which means you're multiplying or dividing by the same number from term to term. If it is division from term to term, you need to think of the value of r as being a fraction. Like in this example here, where we used 1/3 for r. Each succeeding term is 1/3 of the previous term.